Yes.
letter G, I think. It said, like the political polls, and then it says like leaning like left. And
Oh, yeah.
I put ordinal, but I checked the answers, it said no.
And the reason that is, so I would accept either way for that, but I would need an explanation, right? There really is, when they set it up like that, like a spectrum, the left side, the right side, and then the middle ground that almost doesn't exist anymore, that I would argue is ordinal. They might argue that it doesn't really matter what comes first, but it doesn't matter what comes first or strongly agreed or strongly disagreed. What does it really matter which one I put first? No. But then it matters what happens after that. Yeah, so I can understand both on that one. So the book does an okay job with most of their questions are only one possibility, but there are a couple where there's two possibilities, yeah. That would be one of them, yeah. I like it. Some of the questions are freaky, so if I don't get certain questions, I'm worried that nobody's doing the homework, so. Or maybe there's not as freaky as I thought, yes?
So number 58 from I think about 1.2. It was like the most watched television show. I was like, I don't know, I kind of felt like that'd be like categorical kind of.
Yeah, totally.
But it doesn't specify like what kind of genre it is.
Oh, no. It just asked for an example. It didn't ask you to go research the actual answer. So some people said Game of Thrones. It's actually Chernobyl right now, but good try. Last season kind of tanked Game of Thrones. Change my mind. Sorry. But yeah, you can give an example of anything. You can give a shit show just because you like it, and that's an example, right? So don't forget on that section where it's like discrete, continuous, or qualitative. Right, you with me? Don't forget to give examples. It asks you just to give an example. So if it's age of people, you can say 45 years. Just give a quick example. Just actually answer the question. That's all I want. Yes?
I think for that section, instead of giving an example, I explain why.
Okay. I almost like that better, but we'll see how I grade it. Yeah, because they did say give an example, but we'll see.
Yeah, I explained like this is why it's ordinal, this is why.
And I like that better because that's what I would ask you like I did on the quiz, yeah. Okay. All right, anything else from homework stuff?
For section 1.2, number 58, I forgot what problem that is, but I kind of remember. It was like, give like a particular reason or a particular cause for something.
You sure it's 58? Oh, was it the stuff from 1.4? Maybe? All right, find that sucker. Anything else from homework stuff? Okay, just to check in, everybody's able to find the homework, right? I love you guys. They're like, I don't have any questions. I haven't found it yet. Wow. Shit. Okay. You got it?
It was for section 1.2.
1.2.
58.
That's the one we just talked about, the most watched television show.
I'm looking at something.
Maybe it was 2.2?
Can I look in the
Yeah.
homework? I turned it in.
Oh, the homework.
Yeah.
Good. Let's see. So while you're finding that, I'm going to set something up for us to talk about in a minute. What you got, Jeff?
Sorry, I remember.
Everybody copy those down. Yeah, 1, 2, 3, 4, 6, 7, 8, 12. Let's make it 13. Let's make it 14, yeah. 14 data points sitting in a tree. What?
Yeah, it was 1.16, number 48.
48.
Yeah.
Okay.
So for that one, I was confused because
So go ahead and copy those numbers down. We're going to analyze those in a second. The question is that section where they ask you all those population, sample, parameter, statistic, variable data. Right? That's the one we started looking at the other day with the fitness clients or something.
This one was the little pollsters
Yep.
interested in the portion of people who vote for a particular cause. That one I was confused because when they said particular cause, I thought it was like reasons for voting. Like, were you urged by social media? Were you reminded from like,
Oh,
I don't know.
you don't have to bring other things like that into this.
But like, I didn't get what they meant. For
Oh, so when they say, the way I interpret that is they're going to vote for a cause versus against it. Or they could mean vote on a cause, like there's somebody in their house like, I ain't going to vote, wait a minute, I'm really interested in that, let me go vote. So then,
So like it could be like Prop 15. And then
Sure.
Vote on it.
so the way you set up your examples will help me figure out how you're looking at it. But it's not going to change most of the answers based on how you look at that.
Yeah.
Okay. All right, guys. So I want to do a quick review of what we got into at the end of last class. See if you guys remember this. Some of you guys were not here, so remembering is kind of a weird thing. If I just write P 20 down, what does that represent? 20th percentile. All right, so that would be the data point that has what, where? What does 20th percentile always mean?
20th place. Oh.
It would be the data point that has 20% below it. Always. What's the 70th percentile? The data point that has 70% below it. What's the 11th percentile? The data point that has 11% of the data below it. Are you guys with me? Right? We had a little discussion about when is it good, when is it bad to be 11th percentile. Right? That's the only kind of thing you got to be careful about. But percentiles themselves always mean the same thing. This percentage below. So if you scored in the 90th percentile in a test, did you make a 90? Necessarily. I have no idea what you made. But what can I say for sure? You scored higher than 90% of all the other students on the test. Which you could have gotten a 40 on it, right? In fact, I remember my first grad school test, I got like a 49 on it. Yeah. And I'm thinking to myself, what am I doing here? And then the teacher said, oh yeah, good job, Jeff. Because the average was like a 40. And that was just how physics grad school works. Welcome, Jeff. I'm like, oh shit. A lot of curving. A lot of curving. So what's the 2 steps to doing this?
0.20.
Good. 20% of what? Good. And there are how many data points? 14. So that'd be 0.2 times 14 is? It's not 0.5 times 14. It's not half of 14. It's 0.2. What's 2 times 14? 28. So what's 0.2 times 14?
3.8.
There. Okay. All right. Now who remembers? What do I do with that number since it's not a whole number?
Round up.
Round it up. So what's the answer?
25.
Yeah. Third number, 25 is the answer. Is that all right, you guys? This is what we did yesterday.
There's like a homework question where it came out to like 69, and then it ended up rounding itself. No. After like locating the number, which was 69, it ended up rounding up itself to like 70. I was kind of confused on that.
Because the book has a different approach to percentiles. In fact, there are multiple different approaches to percentiles. And they're crap. So you might get some different answers in the book for some of these percentile questions.
Right, so just do it the way you're doing it?
Do it the way.
Okay.
The right way. Yes.
Why'd you use 14 here?
So again?
On the first one, why'd you use 14?
Yeah, why do you use 14? What the shit?
Number of data.
14 data points. Yeah, so I really want this to make sense. Where should the data point be that has 20% below it? about 20% of the way into the list. Right? So yesterday we had 10 here just because I had 10 data points. So it's not always 10. All right. What is sort of special about P25? Why might that be like a special milestone? Quarter. I like it. So we call this Q1 also. So if you see Q1, Q2, Q3, what would Q3 be? 75%, no big deal. Kick ass. All right, it's like quarter 3 is, after the end of quarter 3, you're done with 75% of the game. Boop. So how do I find this? Yeah. How do you get 25% of 14? Cut it in half again. All right, half of 14 is 7, half of 7 is 3.5. Fourth number is the answer. What's the fourth number? 48. All right. So you guys find this. You guys keep going. Find P50, which is also Q2, and find P75. Do those two real quick. I did start this bad boy, right? Yes. Catch up to you guys. Come on, 14. What do I do with that whole number?
You have to average it.
Good. 7th and 8th average. The 7th number is 51 and 54, right?
Wait, is that a negative sign?
No, it's a crappy equal sign. Negative 7th number would be really freaky.
52 and a half. 52 and a half.
Yeah, 52 and a half. Is everybody cool with that? You guys cool with that? So there's the two things that can happen. Whole number, you average that one with the next. Anything else, you round up and take that number. What happened? Exactly what we said yesterday. If you do this first step, and you get a whole number, you average that one with the next one. Anything else, you round it up and take that number. Those are the only two things that can happen for finding these percentiles and quartiles. I like it. Yes?
So the 7th one and then the 8th one we have in the
Yes, because how do you find the middle of any two numbers? You take the average.
So you don't put them in order like that.
You have to. Are these in order? Yes. Dear God. So just to kind of cut to the chase, I put them in order from the beginning. If they're not, does it make sense that if they are not in order, none of this makes any damn sense? And somebody out there is right now going, no, this makes any damn sense anyway, John. He's like, damn. But if I can put it any order I want to, I can make any of these anything I want them to be, and then they don't mean anything, right? So must be in order. Yes, I love it. So what about now, P75? I'm going to do this the long way, and then I'll show you a shortcut. So it'll be 75% of 14, which is 10 and a half. So what do you do?
You located.
11th number, right? You round it up. What's the 11th number?
66.
Okay. Now let me see if anybody understands this. What was Q1? It was fourth number in from the top. What's the fourth number from the bottom? Right? I mean, does that make sense at all? Q1, Q3, they're going to be symmetric to each other. So you don't actually have to do any work for Q3 if you already have Q1. You know exactly how far to go in just from the top. If you don't understand what I just said, do that. What I just said was a shortcut.
If we were to do that rule with P50, how would we know to
Do what rule with P50?
like going to the fourth, but for P50 it would be eighth number, but you still have to take the average.
No. What did I just do? We figured this all out right here, right?
Yeah.
Fourth from the top, from the bottom, sorry, is Q1. Therefore, Q3 would be fourth from the top.
So why can't you go another
P50 would
four
be
for
itself. Do you see what I'm saying? Q1 and Q3 are symmetric to each other. P50 is the middle. There's no shortcut for him.
Oh.
Okay, I like it. Thank you. Yes. So the only shortcut I'm using is I already did all this work to get that. From the bottom, I get Q1. From the top, I get Q3. If that doesn't make sense at all, just do that work, you're fine. All right, so that's your shortcut. Yes?
Couldn't you average the two to get P50? Or just
No,
do that?
definitely
Don't
not.
do that? Okay.
Totally not.
Okay.
Because, all right, don't write this down. But if I were to make this, right? Then it would have been 166 for Q3, right?
Right.
So the actual data values don't relate to each other. It's just
I mean
where
the
they
distance.
are. Oh, distance-wise.
Yeah,
Yes.
not like the average of the numbers.
Okay.
The distance.
Yes, it should work.
Okay.
Yeah. All right. I like it. So notice something about percentiles. Are they affected by large values on either end?
No.
So if I made this 92,000, does anything we've done so far change? No. If I calculated the average though, would that, it goes insane, right? Okay. So we'll get more to that later. Now, let me summarize what we've got so far. Q1 was 48. Q2 was 52.5. Q3 was 66. What's the lowest data point?
14.
He's right in front of you, Jeff. The highest one is 92. It's just the beginning of this class. I know, man. We do a lot each week. Holy shit. Each day. How many numbers are there? 5. And so, the remarkably creative math geniuses, we said, well, let's call this the 5-number summary. Exactly how they sounded. So when they ask you, or somebody asks you, or I ask you, find the 5-number summary, this is what I mean. This is a nice summary of what the data looks like without giving you all the data points. Yes? Say again? What about it? High. It's like the range is high minus low. So the lowest one, first quarter, second quarter, third quarter, highest one. Right? Before the game starts, first quarter, second quarter, third quarter, end of game. Now, yes?
Why is it again when you get a whole number that you get the average of one?
So that was exactly that thing we did the other day. remember we had 10 numbers. The 8th number was not the 80th percentile because it only had 7 below it, 70%. So the reason I did that was to give you guys some basis of a realistic situation. We didn't use a formula. We just saw what made sense. And then the formula says, I agree with that shit. And we're like, okay, formula, good job, right? So I want to give you an example of why that would make sense, that you have to average 2 numbers, and guess what? That shows up in the process we use. I like it.
I was so confused, like when I did P50 and you were like, no, it's not that. I forgot about
Don't forget
why.
that example. That's why. What's in the middle of 5? Let's say, well, how do I say this? What's so if I say what's in the middle of 5 numbers, what is the middle of the 5 numbers? That would be the number in the middle, right? This, no, sorry. Right? What's in the middle of 6 numbers? Well, there's really 2 numbers in the middle, aren't they? So what is the thing in the middle of all 6 numbers? The one that's in the middle of those 2. That's really all this is doing. I like it. Now watch this. Let me go one step further. If I have 5 numbers and I want to find P50, the middle, what's half of 5?
2.5.
Rounded up to the 3rd number, that's the frickin' answer. Do you guys, so the process we use completely matches with what we would do with a small sample. But that process helps me for when the sample is 812 big. I don't know, what? I'm coming. No. I'd rather just do a computation and get there. Okay, I like it. All right, let me see. Now, you're going to love this next thing, or you should. The book, again, horribly mangles these beautiful names. It just calls it a box plot, but is a box and whisker plot. The book just calls it a box plot because they are against interesting names, I think. I don't know. This is officially what it is. And I'm almost certain some of you guys have seen this kind of thing before. So here's how this works. So the box and whisker plot will always be a visual representation of the 5-number summary. So I want to go from 14 to 92. So maybe I can start at 10. And I want to be able to get up to like 100 or something. Maybe see. So all these have to have a place to go. So if I start at 10, let's go by 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Hey, it's not too bad. So one big part of a lot of these problems are going to be figuring out a good scale. Something you should be coming in with is the skill of picking a good scale. Are any of these numbers the data beat any of these? No. Do you notice how I have none of these numbers showing up on the scale? That doesn't matter, we're shit. It could, it couldn't, I don't care. As long as I have a place for them all to go. Right? Okay, now watch. We're going to do this a little differently than what you think. This is not an algebra class. So we don't do little points. Put a line above 14. So 14 is like right there. See that? Just put a line above where 14 is. 48. It's about right there. 52 and a half. It's about right there. 66 is about right there. 92. About right there. All right. That's really exciting so far. Box off the middle 3 like that. Maybe yours will look better than mine. I almost hope yours does. You guys with me so far? So what this does is, let me ask you this. This feels like you don't have enough information to answer me this, but can anybody tell me what percentage of the data is in the box? What's in the box? Yes. 50%. How do you know that? Wizard. Yeah. So what's below this? This one was the 75th percentile. So it's 75% below it. Right? So They're 75% below this guy. And what's below this guy? 25%. So what's got to be in the box? 50%. It's the middle 50%. I don't know if anybody has ever looked at, Princeton has like a book of all the colleges, and it compares every college. And they always tell you the middle 50% GPAs of students coming in, the middle 50% of SATs. It's like the heartland of those things, right? You have your crazy overachievers, you have your crazy underachievers, and then you have the heartland, the average student. You guys semi with me? So if this was grades on a test, oh shit. If this was grades on a test, right? And this is class A, and class B look like this. I'll get there. Same scale, right? But their box plot looked like this. What's the biggest difference that you can tell right away just by looking at these?
The low end? The low end?
What about the low ends?
Like, the low isn't as low on the end. Does that make sense?
No,
Or the
totally.
information.
So this one is more longer. I like it. So that
That's
means the
longer
data
range.
points are more spread out. Beautiful. So this one's much less spread out. It's more concentrated. There's fewer variability in the grades for this guy, right? But notice how half of the students in this class scored above this, whereas half of the students in this class scored above this lower grade. You guys see what I'm saying? Half of this class, is that cool? Because what is this line again?
50%.
50th percentile, so half above, half below. And half of the class scored within like about, 48 to 66, but half of this class scored between below 40 up to 60. You guys see what I'm saying? So this one had less variability than this one, but this class had more people that did better. So if I just make, and that was pretty quick to make, right? But the minute I make that, I can compare data much better than just looking at a bunch of numbers. If I wrote Class B's grades and I said compare them, but if I have a visual, oh, okay, I can make some good analysis just by looking at the picture. That was pretty quick to make. Oh, good. There is a problem in the book where you could have some of these are the same. I think that might be where you're leading, maybe? Yes. All right, so is everybody cool with this? Or, cool might be too strong of a word right now. Is everybody decent with this idea so far? Okay. This is relatively not that bad for us yet. Yes.
Okay, so you say that's the 75 percentile, right?
This guy, yeah. This is
Okay.
75th percentile was this guy.
Oh, okay. I get it.
I like it. That's why that box will always have half of whatever is going to live in that box. So where would my outliers be? Out here. These are possible outliers. Actually, while I'm thinking about it, let me do one quick more definition, and then I'm going to do an example of like somebody over there was talking about with the repeats. Whoever was asking about that. You. Okay. I knew it was in that direction. Let me just throw this word at you and see what you think. This phrase, I guess, is 2 words. Interquartile range. What do you think that would mean? Yes? Oh, okay. What do you know that means? Q3 minus Q1. The range is high minus low. The interquartile range just kind of goes more towards the middle. It says what's Q3 minus Q1. So in this case, what would the interquartile range be? Also known as the IQR. So it'd be 66 minus 48, 18. I like it. Stay with me now. I'm going to tell you this. I'm not going to focus a bunch on this, but this is kind of important to realize. Remember what I said? We just talked about outliers, and I promised you that we would come up with a more objective way to identify outliers. So outliers will always be anything less than, let's say, below 1.5 IQRs. Let me see, 1.5 IQRs below the median, below Q2. So less than that, or more than 1.5 IQRs above, I'm sorry, this is Q1. Okay. So if I take Q1 and subtract 1.5 IQRs, anything below that is an outlier. It's like really low. Half of everybody's in here. Let me take some of this extra stuff away. Let's focus on this. So here's Q1. Q1 was 48. What's 1.5 times the IQR? Oh my gosh. 1.5 times 18.
27?
Yeah. So what's 48 minus 27? So 27 below 48. What's 48 minus 27?
21.
21. So anything less than 21, these guys are officially designated suspected outliers. They are really far away from the heartland, is what I call it. And if I do the same thing on the other side, start at Q3 and add 27, Q1 minus 1.5 IQRs, Q3 plus 1.5 IQRs. That's kind of like where weird starts. And this is working towards, how do you tell when somebody's unusually tall? It feels like it's subjective, but I can make it objective later in this class. We'll figure out something that's kind of related to this. So when has somebody got an abnormally low grade? Officially, it's these guys. Anything below 21. When does somebody have an abnormally high grade? What's 66 plus 27? Anybody above 93, which is nobody. Nobody got an abnormally high grade. And look visually, why does it kind of make sense? Do you see how the box is closer to the... No. It's actually closer to the top. So these are outliers, but these didn't get far enough away to be outliers, officially. Okay, maybe. I just want to put that in there because we all understand the idea of outlier. But this is an attempt at making a process to figure out what could be outliers, officially.